All right, welcome back. So what we need to do before we can actually find the shortest path in a graph between 2 points, we need to just assign values between those points so we can find any path, short or long. And to do that, it's not that hard. All we do when we add an edge, instead of saying from A to B, we just say from A to B, comma, 90, from B to C, comma, 13. So if we hop over to a quick little snippet, we could just quickly redefine our class. So I'll call it weighted graph, and I'm only going to worry about adding a vertex and adding an edge. We won't worry about removing edges and vertices for now, because let's just focus on the important stuff. So class weighted graph, we'll add our constructor, exact same as our unweighted graph. We have an adjacency list. The main difference though is once we're actually adding edges in, what we had before looked something like this, where we had like A, and then it just had an array where we had B and maybe C or something. That's not going to cut it for us, because we now need to store not only the edge itself from A to B, but the value. So it's going to look something more like this, where we have a field, or it's going to be an object, and we'll have two properties. Node, which we'll just say is B, for example, and then weight, which will be 10, a number. And then, of course, we would have the same thing on B, where the node is A and the weight is 10. So instead of just simply the string B, we now need to add in an object. But as far as the vertex, if we had add vertex, it's exactly the same. So add vertex just checks if the vertex is already in the adjacency list, and if it's not, then we add it in and set it to be an empty array. So that's nice and easy. Now we can add in our vertex, like A and B and C. Now to add the edge between two vertices, we need to accept two vertices. So let's go with vertex 1 and vertex 2, and then a weight. And if we look at what we did for our for our unweighted graph from earlier in the course, if you look at adding an edge, it's very simple. We just do this.adjacency list of vertex1.push vertex 2, this.adjacency list vertex2.push vertex 1. So we'll have to change a couple things because I used vertex 1 instead of v1, but that's minor. Okay, so vertex 1, vertex 2, vertex 2. But this won't work because we're not using weight. So remember, we need to store an object inside of that adjacency list. So inside this array we're pushing into, we're going to have an object where there's a property called node. It does not have to be called that, but you could call it vertex if you wanted to. But let's go with node and then weight. And rather than doing this, weight colon weight, because I want it to be called weight, and also the argument is weight, what we can do is just pass in weight here, and it will do the exact same thing as part of, I believe that was added in EAST 2015. It may have been around before and I just didn't know about it. I'll do the same thing here. And that's it. This should be our weighted graph class. Let's see if it works, of course. I just executed the code. So let's make a variable called graph. It's a new weighted graph. And let's do add vertex first. Just say A and B and C. And now let's add an edge from A to B, which is going to be, 9. And then let's do A to C, which will be 5? Sure. And then let's do B to C, which will be 7. Okay, now let's look at the adjacency list rather than just trusting that it works. So we've got A, B, and C. And for each entry in the adjacency list, we have an object with a node and a weight. So for example, from A, we can see there's a connection to B with the weight of 9. And if we look at B, there's a connection to A with weight of 9. From A to C, there's also an edge with weight of 5. If we look at C, where are you? There you are. We have A to C, weight of 5. All right, so this is all working. Like I said, we don't need to worry about removing edges and removing vertices for now because we're focusing on the algorithm, but it's extremely similar to what we saw before, except now you just need to remove an object, but otherwise it's very, very similar. Okay, so now we have all the pieces in place to actually talk about the algorithm. Moving on to Dijkstra's in the next video. So this is our weighted graph class, very, very simple class. might be confusing if you didn't watch any of the graph section. I should have mentioned that earlier in the video, but I did say that early on in this section. So definitely go rewatch that if you're confused about what I'm talking about here. All we did was add in a weight to each edge. So it's a connection from one vertex to another, now with an associated value. All right, next up, we're going to walk through the basics of the algorithm.